Hello everybody, in this lesson I deal with distance, speed and time word problems.
Example 1. An aeroplane is traveling to a destination 2,000 kilometers from its starting point. Strong headwinds slowed the aeroplane by 50 kilometers per hour so that the return journey took 2 hours longer. What was the speed of the aeroplane on its journey to the destination? Now it works like this. First of all, you choose a variable and you say let speed to the destination be equal to x. Then the speed of the return journey will be s minus 50. And then you're going to make a little table for yourself. Now on the left hand side, you fill in your column distance, speed and time. And then on the right hand side here, there's two situations. There was the journey to the destination and then there's the return journey. Now we're going to fill in the values. So the distance for the trip was 2,000 kilometers. That stays the same for both. The speed to the destination is just s. And the return journey speed was given s minus 50. And then time is distance over speed. So what you do is you say it's the 2000 divided by s. And then for the return journey, the time is the distance 2000 over the speed s minus 50. And then in the next slide, we'll look at the sum. We have to make an equation of the situation. And the equation will be the difference between the return journey minus the journey to is equal to 2 hours. Therefore, the time of the return journey from our table on the previous slide is 2000 divided s minus 50. Minus, because the difference between the two is 2 hours. And then the time for the journey to is 2000 divided by s. Everything equal to 2. And there's your equation. Now we're going to solve the equation. So the problem is we need to find an LCD. And the LCD is s bracket s minus 50. And then what we do with the LCD is we're going to multiply every term by the LCD. Therefore, it's s minus 50, and for the second term and for this term on its own here on the right hand side. And then s minus 50 and s minus 50 can cancel, and I'm left with s bracket 2000. And on the second term, the s and the s will cancel, and I'm left with minus 2000 bracket s minus 50. And on the right hand side, it's the 2s bracket s minus 50. Now, in the next step, I'm going to get rid of the brackets. So s times 2000 is 2000s. And then on the second term, I'm going to multiply in the negative 2000. So it becomes negative 2000s. And a minus times a minus is a plus. 2000 times 50 is 100,000 equals 2s times s is 2s squared, and 2s times negative 50 is negative 100s. And then in the next step, I'm going to add the 2000s minus 2000s is nothing, and I am taking this 100,000 across to the other side, and it becomes minus 100,000. And then I want to factorize, but I can also divide by 2 right through just to make it a little bit easier for myself. And now I end it with s squared minus 50s minus 50,000. And I can factorize that one. And remember, if you can't find factors, then you are welcome to use the quadratic formula. But this one, the factors are s minus 250, s plus 200. Therefore, s is 250 or s is negative 200, and then we choose the positive one. Therefore, the speed is 250 kilometers per hour. Example 2. In a race, an athlete has to run 10 kilometers and cycle 50 kilometers. He runs at a speed of x kilometers per hour and cycles at x plus 31 kilometers per hour. He takes 10 divided by x hours for the 10 kilometers run. A. Express the time he takes for the 50 kilometer cycle in terms of x. So we start with time is distance divided by speed. And the distance was 50 divided by x plus 31. B. Calculate the speed correct to 2 decimal places at which he must run to complete the entire race in 2 hours. Now again, let's make a table. On the left-hand side, there's distance, speed, and time, and then the other 2 columns for running and cycling. Now the distance for running was 10 kilometers, and the distance for cycling is 50 kilometers, so you fill that in. The speed for running is x, and the speed for cycling x plus 31. And then the time is distance over speed. So the time for running, 10 over x, and the time for cycling, 50 over x plus 31. And we're going to use the information in the table now to set up our equation. Our equation is running plus cycling is equal to 2 hours. And then, because he takes 2 hours to complete the entire race, now it's time. So the time for running is 10 over x plus the time for cycling from our table is 50 over x plus 31, and both of them added together must be equal to 2. And there's your equation. Now you can just solve for x. We find LCD, which is x bracket x plus 31. And now what we do with the LCD is we multiply every single term with the whole LCD. So it's x plus 31, and x plus 31 for the last term. In the first term, x and x will cancel, and I'm left with 10 bracket x plus 31. Then x plus 31 and x plus 31, the whole thing can cancel, and I'm left with 50x. And then on the right hand side, it's 2x bracket x plus 31. Now, to get rid of the brackets, in goes the 10. So 10 times x is 10x. 10 times 31, 310. Plus 50x equals, and now to get off the brackets here on the right hand side, 2 times x is 2x squared, and 2x times 31, 62x. And now I'm going to take everything across to the other side and add my like terms. And then I end with minus 2x squared minus 2x plus 310. And I divide right through by negative 2. And I end with x squared plus x minus 155. Now I want to factorize. And then, remember I said in the previous sum, if you can't factorize, you are welcome to use the quadratic formula. And then for the quadratic formula, a's value is 1, b's value is 1, and c's value is negative 155. So when I slot all of that in, I end with all of that, minus 1 plus minus square root 1 squared minus 4 times 1 times negative 155 over 2 times 1. And then when I multiply everything out, I end with x is minus 1 plus minus 24,92 over 2. And now I'm going to split this one into the plus and the negative one. So x is 11,96 or x is minus 12,96. And then I'm going to choose the positive one. Therefore, the speed is X is 11,96 kilometers per hour.
In the next lesson, I explain rate of work or performance word problems. Click on the video in the left-hand corner to take you straight to the next lesson.